There it is.
Yeah,
we did it. We made it. Made it once again. Thanks everybody for joining us. This is our live stream, and today we're doing something a little different. It is an Ask Me Anything, but actually it's an Ask Us Anything. Today we have Ty Branaman and Joe Shearer, as well as Matt Bruner, and we're going to just be taking questions from the audience. We also have some backup questions that have been asked and that we want to ask each other should things kind of wind down. The first thing I want to kind of recognize is that Joe is just off of a significant heart surgery that we've all been praying him through, and we're super glad that that you're here with us and feeling a little bit better, Joe. So it's good to have you. And you're muted, but you know, it's okay.
Well, yeah, so I have an excuse, but yeah, thank you. No, I didn't like tell a lot of YouTube people, but thank you, Bryan, and everyone for faithfully praying me through that for sure.
Yeah, so we're really glad that you're doing well, and it's a blessing. So everybody who wants to keep praying for Joe that he would have a full recovery, that'd be awesome. And we're gonna hop right into it. So one of the first questions here is, how can one accurately determine if it's a stuck TXV? So I'm going to start with Ty.
Well, the first thing I would do is pull that sensing bulb off, and I would heat it up in the palm of my hand and see if my superheat changed. And then I would dunk it into some ice water and see if it changed. And if it's not changing either way, then you know there's an issue. Let me back up. First, make sure you get enough subcooling go into it, and make sure you have enough airflow. You gotta have airflow, and you gotta have subcooling first. If you don't have those two things, that none of your diagnostics are gonna work. So once you have your subcooling and your airflow, then I would say pull the sensing bulb off, warm it up, cool it down, see if it changes.
All right, Joe, thoughts?
I don't want to get into the weeds too much, but stuck TXV is a little vague. You know, there could be a TXV that's working completely properly, maintaining perfect 10-degree superheat, but your suction pressure is 40 degrees. And some people might misdiagnose that as a stuck TXV. So stuck open or stuck closed would probably send me in which path I was trying to accurately determine.
Yeah, stuck open or stuck closed. That's the first thing I was going to say. Ty hit on, make sure you have subcooling, and it needs to be at the TXV. So if you don't have subcooling there, so if you have an extended line or a restriction, liquid line restriction, that kind of thing, and you have flash gas, the TXV can't do its job. The next thing is check your superheat leaving the actual evaporator coil. That's the only place the TXV can control superheat, is at the outlet of the evaporator coil. I sometimes call it the constant superheat valve, even though even that's not technically correct. But checking superheat at the outlet of the evaporator coil, and kind of see if it's in that range, depending on the type of equipment that it is. You're usually going to be somewhere around 10. So maybe a few degrees lower, maybe a few degrees higher than 10 degrees of superheat. If you have proper subcool, obviously airflow is important, but a lot of people, the most common reason that people misdiagnose a stuck closed TXV is because they have low suction pressure. And the most common cause of low suction pressure is poor evaporator airflow, poor system airflow. So always make sure that you get that right first. Lots of good content out there about TXVs and how to troubleshoot them. You got anything on this, Matt, or anyone else have anything they want to add?
No, I think that's pretty good.
All right. Let's go to the next one. We're just gonna do this thing, and I'll let anybody take this one who wants to. Can one take static pressure off the side of the furnace for return and or supply?
I don't know exactly what that means.
Can you take static pressure off the side of the furnace?
The side of it?
Yeah, I think that's what he's trying to say.
Lower compartment.
Yeah.
Yeah, you can.
To check static,
gotta kind of be
in the blower compartment.
Yeah.
Yeah, I mean, sometimes you kind of have to if you have a filter right before it, right? I mean, where else are you gonna take it?
Sometimes I'll even just stick a little thin tube into where the wires go through. The thermostat wires usually just have like a little grommet, kind of just, but it's not super accurate, but that'll kind of give you a spot check.
My concern is on the side of supply would be the baffles in there, and you're having your airflow and your different rates. So having it in the side isn't giving you a true reading. So I'd really prefer it to be after the furnace or between the furnace and the coil. You know, if you can get in there somewhere, I'd prefer that.
I mean, you're only going to have the limit switch though, right? I mean, that's really like a lot of people like pull the limit switch.
Yeah, it's kind of a little bit hard to tell exactly what they're asking.
Yeah, it's tough to know exactly, but to the point of, I think, maybe the heart of the question on a furnace, you know, you're supposed to check static pressure with whatever comes in the box. So in the case of a fan coil, the evaporator coil comes in the box, and so you can measure, generally speaking, after the filter. Some cases it even includes the factory filter, but after the filter and in the supply duct with the furnace, you have this issue because the coil doesn't come in the box. And so the right way to do it to measure your supply is in that, you know, hopefully you have some sort of a transition, but in a lot of cases you don't. That's the right place to measure static pressure, which is very challenging. And there's not like one right answer to that question. As far as where you would check your return side static pressure, you would generally measure it in between the filter and the furnace. And sometimes it's just as simple as, you know, taking your probe and kind of getting it on top of the filter. If your filter cabinet or whatever, you're generally not going to, there's not a real perfect world for a lot of this stuff.
Yeah.
All right, let's go on to this one, which I kind of like. Do all ECM motors work the same? I wish we had our friends from Regal here for this one, but anyone want to take it?
The answer is no.
Right.
So there's like really two types. There's the constant torque, which is like has I don't know how many speed taps, usually 5. And so that's just kind of like the board sends 24 volts to the motor and it runs at one of those 5 speeds. It's kind of like a PSC type setup. And then you've got the, like, I don't even know what fully variable ones that can do a lot more variation in their programming than that. So those are the two basic types. The ones with the 5 speed taps are way easier to like test and figure out if they're wrong. You just look for a high voltage and then 24 on the control terminals. The other ones, you've got to have like a motor tester, and there's a bunch of different types of plugs and things like that.
Yeah, I'll add to that quickly. There's actually 3 different standard types. Then you have a bunch of subsets across these 3 standard types. You have constant torque, which is the one you mentioned, often called X13, because that was one of the first that came out. And that's not really adjustable on the fly. Then you have what we would call the fully variable. And that was what we traditionally called ECM when it first came out. And that was what we call constant airflow. And so it's actually programmed where you can set the actual airflow. And then you have constant speed. And that's the one that we sometimes miss. And constant speed is what are used for ECM condensers. So ECM condenser fan motors. And those are they just run at a fixed speed, because the assumption there is that there isn't going to be large variations in load on the motor. How they're troubleshot and all that, it does vary quite a bit. And, you know, you said 24 volts, but there are even DC signals in some cases. There's a good wide range of different ECM. I always want to say ECM motors, but that's motor, EC motors, or however you want to say that. There's a wide range of them, but they kind of fall into those 3 typical buckets, and they're definitely not all the same in how they function. Any comments, Ty?
Every single time I take a Regal class, every time I learn something new and a whole nother depth. And I think I've already seen that. I'll watch it again just because they are so smart, and the information they give it will blow your mind of all the details that go into that.
Yeah, take a class from Chris Mahali or watch him online on this topic. Chris is the guy. He's your man on this topic. Anything you want to add, Joe?
We'll play devil's advocate for a moment and say, but do they all work the same? And say, yes, they kind of do all work the same. You got different inputs, different modules, different programming, but at the end of the day, can you learn how it functions? And that's is across the board for all of them.
Yeah, especially in the sense that they all have some sort of a module, which is basically a variable frequency drive of sorts. They all have permanent magnet rotors on them. So they're very similar in that way. They all have a way of kind of knowing how fast they're spinning. because of the feedback from the permanent magnet rotor. So yeah, there's a lot of similarities there. All right, this is one that's kind of a we're going to do this one. This is kind of a tough one, but I'll let you take this one, Ty.
I don't. Pressures mean nothing to me. I want saturated temperatures. On a mini split, it's a little different because you can't do superheater subcooling. So I don't really use pressures for mini splits. I pull the charge and I weigh it back in, and mainly because if they're having an issue with it, a lot of times they didn't plug it back in the first place. There's going to be moisture and acid I want to clean up. But Craig Michelaccio has a great step-by-step of how to get an idea on your pressures while the system is running, as far as what's a good pressure change with temperature. So every time your fan motor is changing RPM, your indoor temperature is changing, your outdoor temperature is changing, your pressures are going to change with that.
Yeah, on this topic, if you want to know more about mini splits and ductless and how they specifically work, then get Craig's book on this topic, because he does dig in really deep. But the challenge is exactly what Ty just said. It's like there's a lot of ways that you can kind of get a sense of whether they're working. You can do things like looking at delivered capacity. You can even just look at supply temperature at full speed. You can look at suction temperature to some degree. But I really don't advise that you're connecting to the pressures on a ductless system regularly anyway, because they have very small charges and you're likely just going to make things worse. I've seen more ductless systems just vastly overcharged because people are trying to get a better split out of them or something, just jamming more charge into them. So you're generally going to be in a worse situation. And like most things, if you really suspect that it's very low, then you're going to see significantly lower suction pressure than you would expect, and that's just based on suction saturation, right? I mean, it's the same sort of rules of thumb that we generally see. It just depends on how it's actually set to run. If you have it set up on fully high speed, or if it's on some lower setting, or if it's in some sort of dehumidification mode with blowers running lower speed, something like that. But delivered capacity is a good way. So if you don't have a good way to do that, I would definitely suggest that you get a good way to do delivered capacity. Job link probes, measure quick, something like that.
Yeah, and it's not that hard because you know what the airflow is, or you're at least close, right? You don't have any duct work on it.
Yeah.
So, yeah. I mean, I've put probes on them. Yeah, I'm just looking for like 40 degrees, and then I'll check the superheat coming back. You can tell some stuff. Yeah,
if you set it way down, you're generally going to see higher air temperature splits and lower suction saturations than you would see in a regular split system if you really jack the temp down. That's again, but those are all. It just depends on the conditions you're running in. Depends on the particular manufacturer. There's a lot of but ifs there. I'm going to give this one to Joe. So Joe, how would you, to somebody who's asking this very, very big question, how do you install an air handler in an attic? I know you've done a lot of that. I've done a lot of that. But what are some of the main things? Like, hey, remember these few things when you're doing it in an attic.
Yeah, I would start with a solid level platform. I typically I don't like to hang them, but I know some people do. Drain pan that covers. I like to kind of use bigger is better mentality on an overflow pan. Also know, if you're building a platform, or even once you've demoed the old one, go ahead and take a second to try to give it a little bit of a bubble on the level towards the service doors. Give it a little bit of a positive slope, and definitely make sure it doesn't have a negative slope. So if it's, because that also comes into effect when if you stick a 6 or 7 inch piece of PVC off the pan and the whole unit's like this a little bit. So definitely take some time, level up your platform, and start with a good foundation. What do you think?
Yeah, I like redundant float switches. So have a float switch in the air handler, have another one in the pan. Make sure that your pan, like you mentioned, is level. Make sure that it overlaps on all sides. Make sure the pan is well supported, especially if you're going to hang it. Think about if that pan is full of water, is it going to collapse all over the place? Another thing is make sure that you look at the manufacturer installation instructions on doing horizontal left, horizontal right, because in some cases there's different things you have to do. Some cases you need accessories. Sometimes you have to move things around, seals, all that kind of stuff. So make sure you know all of those installation instructions for the different configurations. of the pans. And then another thing, if you're asking just like how to physically do it, we'll pull the coil out. I mean, pull the coil, pull the blower housing out. So that way you're just going up with the shell of the air handler and then bring your parts in kind of one at a time. But level, make sure you get your drains right. Make sure you read your installation instructions for the different side configurations. That's where you see a lot of dumb stuff happen. And then make sure that your ductwork is well attached. So you can't just, especially if you're doing like a board and mastic situation, don't just let the mastic be the thing that supports those ducts. They have to be independently and solidly supported right at the equipment. I've seen a lot of ducts fall off and not ducts. I've seen ducts fall off too of things, but I'm talking ducts. Ty, do you have anything?
RTF film. Before you install it, read that manual. People ask me so many questions about it, and there's so much stuff in the manual, and I get it. I struggle reading, but take a highlighter and break it down in little sections. Even like how the suction line, should it have a riser or not? That's actually, it's in the outdoor manual, but that information's in there. And about the coil, which way it turns, air sealing, air flow. If you're every CFM, every cubic foot of air that leaks out of that ductwork into the attic is having to be replaced into the house. So you have a triple loss there. Think about the next person that's going to be working on it, because it may be you, maybe me, and making sure it's easy enough for that person to come in. And don't just be cutting 2x4s. It sounds like, hey, you can just chop this out of the way, but a lot of these houses are engineered, and if you cut a board, it can cause a lot of trouble. And that happened at a company I worked for. So just don't be cutting boards.
Yeah, good stuff. Matt, you have anything?
No.
Oh, good. Well, that's simple.
Couldn't think of anything on this one.
We have one thing that I'm learning so far is that we need to do this more often, because we're getting a wicked amount of good questions. So this is really awesome. Keep them coming, because we'll roll these into the next time we do this. We're definitely not going to get to all of them. Is it worth getting an associate's degree for HVAC? I like this change of pace here. So Matt, I'll start with you. Do you think it's worth it?
I don't think it's worth it. I think it's better to just start as an apprentice and learn on the job, because you go to school and you spend maybe a year or two getting all of this education. But then when you go into the field, you're going to get paid the same, honestly. And so it's kind of like starting from square one. That's been my experience, kind of seeing people come in from different ways. And I think it's kind of one of the best and the worst things about the industry is if you are really motivated, you can kind of like leapfrog past a lot of people, because there's not a ton of structure, at least in some places, in terms of like how, plumbers have sort of these different benchmarks they have to hit. For a lot of places, there's not a ton of that for the AC side of things. So for me, it was beneficial because I could move up pretty quickly. So no, I don't think it's worth it.
All right, Joe, you think it's worth it?
It would depend on what you want to do in your career in HVAC, I think. If you wanted to be a great technician, maybe not. I hope you're mechanically gifted. But if you want to like be a business owner, or maybe you want to do something else in the field where this would come in handy, it might get you in the door to some places that someone with just field experience wouldn't. So, and probably for running a business, if they taught you a lot of business stuff, it would be good for you. Depends how much it is too, I guess.
Yeah,
Cost you $200,000 or $300,000 for it.
Yeah, it's cost benefit analysis. I think is huge. Ty, I'm sure you have an opinion.
Oh my gosh, yes. So it depends on what are your goals. Like, what are you trying to do? If you're just trying to get started with the trade and get a job, no, it's not necessary. But I've worked for some corporations that if you didn't have that, you weren't going to move up. It didn't matter if you knew 12 times more than the other person. If you didn't have that paper, you're not going to move forward. And I think a better question is what school? Because an associate's degree doesn't mean anything to me. What was the school? What did you learn in the school? What did you apply? What was your attendance like? What were the instructors like? Because I've been to schools that the instructors didn't care, the administration didn't care, no lab equipment, and I've been to other schools that instructors poured their hearts out. I've seen schools that had every piece of equipment you could possibly imagine, and there's so much stuff to learn. So I'm really torn. The biggest thing is you have to learn somehow. I see technicians that have been, oh, I've been doing it this way for 25 years. Well, you've been doing it wrong for 25 years. I wouldn't be bragging about that. So the big thing is learning. Now, if you have to go to school and sit in front of somebody to learn, or if you're going to learn on your own, or you're going to learn here, you have to keep learning. And I keep learning all the time. I just was in 2 classes today learning stuff, and you have to keep learning. And however that process is, that's the key to it all. Keep learning.
Yeah, it's good. I agree with you guys. All right. So does the air handler being in a hot summer attic cause a lower temperature split? I'll take this one right off the bat. Generally speaking, because again, both your return and your supply are in the hot summer attic. And so it depends on where you're measuring your temperature split. If you're measuring your temperature split at the return and the supply grills, which I don't recommend you generally do unless you're doing both, then yes, of course it will affect that. It'll definitely decrease it. But if you're measuring it right at the equipment, right before it goes in and out of the equipment, could it have a nominal increase just because of the heat on the cabinet? Maybe a little bit, but not generally. It's not going to be significant because they're both going to be affected. That's my thoughts on that. Anyone else?
Yeah, if you having air leaks in the attic, is your ductwork the right size in the attic? I think just the attic itself isn't enough of a qualifier. But being in the attic has other factors like air leaking, which is huge.
Yeah, I think Brian, what you said is a good test. Like sometimes I'll check that. I'll check the temp, like I call it like a delivered capacity or a delivered temperature split.
Yeah.
And then you'll go up in the attic and check it, and you're like, okay, the equipment's fine. There's
Right.
nothing wrong with the box that's making the cold air. It's the distribution system to get the cold air to the house that's the problem. So it can be a really great test.
And that's actually something that Bryn Cooksey, he calls a duct efficiency test. And that's exactly what he does. And he does he divides those 2 numbers and comes up with a percentage and basically says, hey, this is the percentage of capacity that you're actually delivering based on what the equipment's producing. And it's a good way to assess, are there things that you should be doing? Now, you can say, well, it's just the ductwork, but it's not just the ductwork. It also can be the attic. If your attic is 150 degrees because it's poorly ventilated or whatever the case may be, that can be another factor that you may not have a ton of control over, but it is something to certainly consider. All right. Hey, here's a different one. Thoughts on performance pay. I definitely have some thoughts, but see if
Let's
anybody
start
else
with you
has
then, Brian.
Well, hey, I don't want to start every time. Okay. So I came from a company that did performance pay basically across the board. I am not a fan of it across the board. I am a fan of it in cases where production is the most important thing. So, for example, if you're doing a bunch of duct work on a big commercial facility or in a multifamily facility or something like that, where repetition and production, it becomes the most important, and you have on-site management and on-site QC doing punch lists and checking over everything and making sure it's all being done, then that can work really well. And typically that would be piecework. And so it can work well for both parties, right? You can make good money doing it, pumping out a bunch of work and that kind of thing. But generally what we're talking about here is service techs. And the problem with doing it with service techs is service tech is alone with Mrs. Johnson and her air conditioner. And when service tech knows he can make more money by selling a whatchamadoodle, or in the case of the company I used to work at, it was contactors. Every contactor was pitted for some guys because every contactor is a little pitted, right? Every contactor is not perfect on the contact points. Now, how often do we actually see systems fail because of bad contact points? We have seen this rash of them failing because of coils, but the points rarely cause residential systems to fail. Commercial, bigger systems, they certainly is more common. 3-phase, it's actually a pretty big deal. But if you know that you get an additional 50 minutes or 60 minutes to install a contactor, you know it's only going to take you 5, and you can add that to the service ticket and make more money. Man, that's a tough incentive. That's a tough carrot to put in front of technicians' faces. Or if you tell them you get 90 minutes to do a maintenance, and if you do it in 45, you're making a killing. Man, it's tricky. It incentivizes people to rush. And we know in residential, it's very hard to provide quality control because you have this distributed team. It's not like you can have somebody watching them all the time. So I'm not saying it's bad, but I am saying it's something you have to be very, very careful with. And there are spaces that it makes a lot of sense and it can be a win-win, but it's always something you got to watch for because it incentivizes people to work fast, not necessarily to be honest or to do quality work. Ty, you have to have thoughts on this.
I absolutely have thoughts. So my personal experience when I first had a company that was trying this out, it was great for me because I was able to make a lot more money because I was able to show my skills that I'd learned more than just how many years I'd worked. So I was able to move forward a lot faster. Now, on the flip side, that I've been able to experience things from all across the country. I've seen people work hourly that say, I don't want to work any faster. I'm paid by the hour. And it's like, well, that, about some pride in your job, And then on the other hand, I've seen technicians that literally rip people off. And even worse is now there's a lot of companies that are promoting that. Sales is that triggers me. No, you got to take care of your customer. Now, maybe your customer needs, they don't have a flow switch. They need a flow. Maybe they need some of these things, offer it to them. But when a technician's brought in and they're having to have a conversation over their sales and their performance and they didn't get enough sales in, it's broken at that point. Like, we're not door-to-door salespeople. We do have to give people options, but to give performance pay can be it's a slippery slope that ends up being a lot of people. I have people calling me saying that their grandparents are ripped off, or elderly people, calling, and I've heard about you online, and these heartbreaking stories of how a company ripped them off. And it just, like, some of the elderly, some of these elderly have such fixed incomes that they have to choose between dog food and medication, and then somebody's having them sign up their house to get an air conditioner when it just needed a capacitor. So those things are it gets me very worked up. So there's not a one answer fits all. You have to have integrity from the top all the way down, regardless of which method it is. It takes integrity. And how do you teach somebody integrity? How do you pass a law to have integrity?
Yeah. But to your point, like, it's not a one size fits all. It's not like good, bad, right? It's like, what are you actually incentivizing? So for us, there are some spiffs that technicians can get. There are some that they generate leads. They can make some money, but it's not that much that it's going to change their life. And also, we're really taking into account things like customer satisfaction and all that as part of that equation. So I think there's ways of doing it without overdoing it, where you're still focusing on the right thing. So I don't think it's one size fits all, but nuance.
I've met the guy from Kalos, and I believe he has a lot of integrity, and I think that makes a big difference.
Well, I don't know about that. You need to talk to his wife about that. All right. So how does the temperature before and after the condensing coil drop so much, but pressure doesn't? I thought pressure and temperature had a relationship where lower pressure equals lower temperature. So this is one that it's a good one because it illustrates a common misunderstanding. So we see a temperature change in a condenser coil as an example, because there's actually three things happening inside of a condenser coil. First, it's fully gas and we're de-superheating. So there's a big temperature drop there because it's all gas, right? It's all gas. So this idea that there is always a pressure temperature relationship is technically true. Joe and I had a whole rigmarole about this once. It's technically true, but when it's within the same phase, it's much less than it is when we're actually changing state, right? So when we're changing state, that's when we see this fixed temperature pressure relationship, much more so, what we're used to seeing on a PT chart. But we can de-superheat. We can go from coming out of the compressor at 225 degrees down to a condensing temperature of, say, 120 degrees and see very little pressure change, nothing significant. And then we get into that condensing phase where it does stay the same pressure as it's changing phase. And then we get to the subcooling phase and the same thing happens, right? That temperature drops because now it's fully liquid. So you have to always, when we're talking about pressure temperature, we're talking about the saturated state is the main one we're thinking of, but there is also this gas law thing where you do have changes in pressure and temperature associated with that, but never confuse the difference between contained and uncontained systems too. That's a whole nother piece there that kind of adds to all of this. We've got this contained system, which also has a big effect on it. So there's a lot of other principles here that we'd have to get into to explain that. But anything you want to add on this one, Joe? Because this does kind of speak a little bit to some of what we were talking about that one time.
No, that was good. I mean, in a dynamic system that's running, like you said, you're only going to have that PT relationship in two places in that entire unit. So you can't really just take a measurement anywhere willy-nilly and think you can accurately plot the pressure from a temperature because it's all dynamic. So,
Right.
Yeah.
Yeah. If you have saturation inside your evaporator coil and a part of it, the bottom part of your evaporator coil, and you have it in the middle part of your condenser, and those are the two places that PT relationship holds true. Other than that, you're going to see different things, right? That's what subcooling and superheat are. All right. Well, here's a really big one. How do you properly size the return and supply on a system? Who wants to take this bad boy?
So I think, I mean, it kind of, if you're out in the field and you're just looking at like what's there and you're kind of trying to make an assessment. I mean, I like what I think Russ King has said this a lot. Like you can kind of start to like add things up to some degree that can be helpful. Just, you know, looking and saying, okay, this is a 4-ton and it has a, you know, a 16 or an 18-inch return or something like that. That can give you an idea. Pretty much all filters are undersized. Like you need a really big filter to get a good filter pressure drop. So you kind of just know that most filters are undersized. So you've got to have a big filter, and then, I mean, yeah, the right way to do it is to use like manual D, or just make everything super big.
Yeah, and the other thing, what I would add is a lot of people have pointed out that just looking at your velocity can give you a pretty good indication. So kind of keeping getting your return velocity as low as you can get it. Make your ducts as big as you possibly can near the equipment on the return side, especially. Just upsize your filter, upsize your return duct. It's not going to hurt anything to do that. And then on the supply side, if you can use something like a ductulator or any sort of a duct calculator, and you're really just kind of looking to get that velocity, you know, ideally in that, 600 feet per minute range is a pretty good rule of thumb. You're generally going to be pretty close. And we're talking about field assessment here. Like you're in the field and you're trying to say, hey, what's the velocity? So first you need to know what airflow should this system be producing. So you have to know that, that's a pretty big ask. And then you calculate, okay, based on the size of this duct. That's field assessment. If you want to size it properly, as in you're designing a system, well, then you need to use manual D. That's currently the way to do it. And a lot of that comes down to, we'll just make it as big as you can and use low friction fittings near the equipment. And then from there, that's where the design really starts to matter. But mostly it's dictated by size and space. If you can get bigger near the equipment, then get bigger. You can put a bigger filter cabinet in, put a bigger filter cabinet in.
Still use hand dampers in your supply ducts. Don't
Yes.
Bet your life on your calculations.
Right, and that's a big thing. You can oversize ducts all day long, even on your branches, so long as you're using manual dampers and you're sizing your grills properly. Your grills have to be sized based on throw and mixing, but you can oversize your ducts. Just have adjustable manual dampers in place.
Yeah, because the manual D is sizing for the longest run. So all of your other runs are oversized. Is that correct? That's kind of my current understanding.
You can do so. Like software can downsize. I forget the term for that. Yeah, it can downsize those for you. But in commercial, you see it all the time, right? If you go to a commercial structure, it's like everything's an 8 or everything's a 10, and it's just these big trunk lines, and you have manual dampers, and like, how does it work there and not in residential? Because it's the same. It's just in residential, we often don't have the access. In some cases, access is a problem. But also we're just usually trying to, we don't have space, or we're trying to save a few bucks on material by downsizing the duct. But when in doubt, if you feel a little nervous and you can put bigger ducts in, then just make them bigger and use manual dampers, and you're going to be fine. I mean, I've done that like 100 times in the field where it's like, I don't want to do a whole new manual D here. I know we have a problem over on this side of the house. Just put bigger in that I know we're safe, and then use manual dampers and use the airflow hood and balance it out. So, of course, everybody has an airflow hood out there in podcast land, I know. So we have no problems there. Here's another one that I like. Is there a consistent way to diagnose which part of the ECM blower motor is not working?
You can smell it a lot of times.
Give it the old sniff test. I like it.
Yeah, I mean, sometimes you can walk into somebody's house and you just smell, okay, yeah, I think it's the little module. I mean, I think most of the times it's the module. Is that correct? Is that?
The vast majority of the time it's the module. But that's not the answer to the question. The answer to the question is, how do you know?
So
So
you can take the back of it off and
There
actually
you
look at the board, and you can see it's usually, I think there's like one, I don't know what it is. It's like a little circle with 2 wires on it.
That
Yep.
thing's never bad.
Capacitor.
Don't even
I
waste
mean, the
your
motor
time.
almost never is bad, but if you want to be technical,
Little-
then you can check
that
the
little
motor.
disc is never.
Are you being
That little,
sarcastic right now?
PTC disc. No, that little PTC disc. Is that what you were talking about, Matt?
Yeah, isn't that the thing
Like,
that's usually
just-
all black and burned up?
I mean, I've
Purge.
only found like 1 or 2 of all the bad motors
Oh.
that are actually bad. It's usually something wrong with the the triax and that does all the switching and stuff in there. It's usually never that little thing. So
Yeah.
it's like, but yeah,
So-
you can, even like just if you said a consistent way to diagnose it is like if the motor's kind of doing that rocking thing. I mean, I think you could assume with a high degree of accuracy that you're getting the call at that point. You're getting voltage at that point. And also, when a module shorts out, it almost feel like it's got electric brakes on the wheel. So I don't know if anyone's noticed, you'll spin the wheel and it's got like brakes on it, and then you unplug the module and it goes away. That's definitely the module's bad for sure on that.
Yeah, I mean, it kind of doesn't matter though. It's not like you can just get a module, can you?
Yeah, you can.
Not
I mean,
a
there
lot
are
of
some
times.
cases
Not a
I
lot
have.
of times.
I have
Oh, yeah.
in the past, but it depends. But anyway, so to know for sure, take the module off the end. So look to see if you have the proper input. What is the proper input? Depends on the motor, right? So you have to know that. You see if you have the proper input. If you have one of those testers, you can drive the input with the tester, which is generally what you would do. You just plug it in and you'd use the tester to give it the input. Okay, I got an input. It's still not working. All right, that leaves the motor or the module. Pull the module off the motor, spin the motor, make sure the motor's not like got anything crazy going on. Now you will get a little indexing on ECMs because they have permanent magnets in them. So you get a little bit of that, you'll feel that in there. That's normal, but it should spin free. And then you can go to the little plug and ohm them all to each other. It's a 3-phase motor, so they should all ohm the same. And then you can ohm them to ground to make sure they're not grounded. They never are, but you can do it if you want to be technically correct. And then at that point, the motor's fine. And then you could theoretically replace the module at that point. But in most cases, you're not going to be able to. So what's the point? If you don't have proper inputs, in most cases, if you have proper inputs and the motor's not running, you just replace the motor module on with your merry way. Pretty easy diagnosis.
And the wheel has to be completely still if you're going to try to ohm out that motor.
Yes.
Because if it's
correct.
even moving a fraction of an inch, your readings jump all over the place, and you'll think that it is bad. And so it might actually be better if you're gonna is go ahead and pull it out of the cage and have it really just sitting completely still, without attached to a wheel in a cage.
Yeah, that is true. That is true. All right, we're not going to answer the question of which brand is best. That is a third rail. So how do you calculate how many CFM is required for a room or a space? This is actually kind of a fun one because there's a right answer and then there's also an easier answer. The right answer, of course, is you have to do first you have to do a room by room manual J, right? And then you have to do a manual D and calculate how many CFM based on that. But if you do a manual J and you already know how many BTUs are required, a room by room manual J, and you already know how many BTUs are required in each room, then you can take your total system capacity and you can just divide it by those, and then figure out, you take your total system capacity and your total system airflow and basically just figure it out that way. This is pretty easy at that point. That's easy math. But even beyond that, if you really just want a quick and dirty measure, you can really just look at square footage and say, now, again, it's going to vary based on windows and occupancy of each room, but you can get a pretty good sense just by looking at square footage and dividing that by your total system airflow. So each space, look at how much square feet you have, how much airflow does the system produce, and you'll get a pretty good sense. Now, again, people are going to be screaming and their hair is going to be on fire. It's like, no, that's not how you do it. I get that that's not how you do it. You do it by a manual J and a manual D room by room. But a lot of service technicians, you just quickly want to know, hey, is this in the ballpark of the airflow I should be getting out of this vent? I don't have a manual D available to me. And you can do that pretty quickly. And again, you have to know things like what your target airflow per ton is in your particular market. In our market, it's 350 CFM per ton. Calculate that, multiply that by your tonnage, and then you're going to come up with a number. And then you just divide You just divide that by your square footage, and that'll give you how many CFM per square foot. Which again, not perfect, but a way that you can use. Thoughts, Ty? You're smirking nervously.
Well, I was just thinking after listening to Ginry and the TEC, the roomulator. So it didn't matter how much air you have going into the room. A lot of times it's not getting back out. So making sure crossover vents or air pressure across that. I mean, I've learned so much from Ginry watching his articles and what he does. Changed how I look at things.
Yeah, on these sorts of questions, if you're asking these sorts of questions, I would strongly suggest that you get some education from NCI or Ed Jonawalk, listen to Jenry Garcia, watch the HVAC Grapevine, guys who talk about this stuff all the time. Get familiar with Quick Model, Design Suite, Alex Meany, Mean HVAC. These are the guys who talk about this stuff all the time. I'm often thinking like a tech. And so a tech has to sometimes have some quick and dirty answers just to sort of get by to get a sense of what's going on. And that's what I'm giving you. But the correct answer is you need to learn how to do these things from guys who actually are really good at that. And that's more the design side. All right. This is here. We got a tech support question here. All right. So tech support question is: struggling with an older Lennox package unit, blower will randomly drop out and unit will start to freeze. Still has 24 volts on the green wire, no amps on leads. I don't know what that means. That's a little concerning. Can hear relay click off, then back minutes later. So it sounds like the relay is actually dropping out, even though he has a consistent G call. Any thoughts there?
Yeah.
Bad relay?
I would. Yeah. I mean, what kind of relay is it? Is it on the printed circuit board, or is it just like a cube relay or what? But yeah, I mean, if you can get it to do it like that, you're there and it does it, you're already pretty dang lucky if it's doing this and you watched it. So jump it out. But you could even just put the voltage right to the obviously check and make sure your amps aren't over your full load amps on the motor.
Mm-hmm.
I've also still seen motors that are older and going out, even though the amps are fine, they will start to drag and bog down and shut out. But you said it came back on again. That usually doesn't happen if it's a motor. So I'm leaning more towards your control there.
Yeah, I would say bypass the switch and run the motor without the relay in it, and that way you'll know.
Okay, so design. When you design a system, you design it for a heat load, and you design it for the outside condition to be within 1% of the design, and every city has that. So anytime it's above that 1% design condition, it means less than 1% of its total runtime, it should be running nonstop. And a lot of people will do sizing just off of that runtime. So if the unit short cycling when it's above its hottest day of the year, then that's a really good sign that it's too big for the house. And if it's too big for the house on the hottest part of the hottest day, then it's also going to be too big for the rest of the year. And we think about cooling, we think about changing the temperature, but more importantly is humidity. And it takes run time to have humidity. So if it's above the 1% of the year, when it's going to be the hottest it possibly is, and it's cycling off, then it's not going to dehumidify the rest of the year. And when we talk about it being 100 degrees, but like it should run all day. No, it's only at that 1% design condition, maybe a 4-hour window of a 24-hour day. So it's not like it's running 24 hours a day nonstop. That's a different issue. That 4-hour window, when it's above that design condition, at that point, yeah, it should run all day. And in some cases, you may even lose a degree of temperature, maybe even 2 degrees. Ooh, 2 degrees. But if it's running correctly, it's dehumidifying, and the temperature is feels much more comfortable. In other words, people will say, I want my house at 70 degrees, but that means nothing to me without a humidity reading, or at least a dew point reading. I need some kind of a moisture indicator, because that's going to have an effect on how we feel. So when somebody gives me a temperature at what they're comfortable at, I'm just like, whatever, because it doesn't mean, it's like saying green. Like, what does that even mean? Nothing. We have to have a reference. And what you find, if you do a system correctly, it only runs that 4 hours during that 1% of the year all day. But then the customer has it at a warmer temperature because it's dehumidified. and now their house is healthier. And you see some of these mold remediators going through and finding houses with mold all over it. People think it's dust, but it's mold from high humidity. And they're having to turn the temperature down lower and lower, trying to offset the humidity. So now they're having to keep it at 68 because the humidity is at 70% for them to feel comfortable. So anyways, that's about as short as I can make that.
Yeah, and I would also add, it really depends on your market, right? There are markets that are dry and arid where oversizing doesn't have a humidity consequence. And so in some of those dry, arid climates, you can get away with it a little bit more. But even then, oversizing has an energy consequence, regardless of whether or not it has a dehumidification consequence. So we do not want to be oversizing equipment, at least not radically oversizing, for both reasons. If you do things like you put in a whole home dehumidifier to help deal with the latent load during those sort of shoulder seasons, and so you oversize and you're using that as part of your strategy, you can get away with it. In commercial, they oversize all the flipping time, but you do these other strategies, so you have additional dehumidification capacity, you have DOAS units, you have all these different things to help deal with it. But the answer in residential is you don't want to oversize. And that does mean that on the very hottest times of the day, on the very hottest days, it will run nonstop. And sometimes it'll get a little behind, and then it'll take a few extra hours to catch up at night. But if you have a system that's not recovering at night, then that's probably a different problem. And again, it's not always the equipment. It's often the ductwork. It's often the envelope. It's often the attic temperature. A lot of other things that you need to be looking at that is not just the AC equipment. So just sizing, pretending like it's the equipment sizing problem every time it doesn't get cold enough in the house, that's another major epidemic that we face. And we have to educate ourselves about some of these other potential causes. And it's not just the equipment. And that's where things like learning how to do a delivered capacity calculation and you're learning how to use tools like TrueFlow to confirm airflow can give you the confidence that the equipment's doing its job and it's probably something else in the house, whether it's ductwork or something else that's causing it. I'm going to get to this question. This is one that I like. I want Joe to comment on this one. Why on some condenser units does foamy refrigerant leak out when disconnecting gouges? I think we mean gauges. Sorry, I was just being silly there. Is the refrigerant a problem?
No, it's just, maybe it's just dynamic too. It's a dynamic system. So on one system, you replaced a capacitor, okay, and that thing was sitting off and humming and the oil was kind of stagnant in the lines, and then you fired it off and put your gauge on it and it kind of shot a little slug into your gauge. So it's just all about kind of what's going on with that system. And obviously systems that are low on charge and you add charge to them, all of a sudden the oil's starting to come back to it, and then you find that a lot more, stuff like that.
I'll also add additives. It can be though. So it could be.
I mean, I guess
if you have cases where you have really low airflow, and because of that, you've got poor oil return. You'll get some cases like that. You'll get some cases where, and again, if it's low airflow and poor oil return, it's been off a while. There's just different factors that can drive it. Maybe somebody put a lot of additives in it. Maybe they swapped a compressor with another compressor and another compressor, and now it's got way too much oil in it. What you're seeing is oil, almost certainly. It's not. So the answer to the question, is the refrigerant a problem? No. I mean, it's not necessarily. It could be, but that's not why you're seeing foam. The foam is oil that you're seeing there. So you can't just tell anything just by seeing that, though. Anybody else have any thoughts?
No, it's a good question. I've always wondered too.
All right. Thoughts on how the industry is becoming more complicated, expensive, more regulations, pricing out lower tier customers, and making it more difficult for smaller shop operations to provide service. Ty.
So evolution is a thing. Like air conditioning wasn't even here 100 years ago. So we have evolution, and as things grow, they become more complicated. Look at cars. Look how much cars have changed. And if you think before, cars would be worn out, before 100,000 miles, and my car has 300,000 miles on it, and it's part of the evolution. As you see, auto mechanics are having to get new tools, new training, and it's just part of what we have to do. I mean, it seems like everything, how we build houses now has modified and changed. So we can't fight that change. We can adapt to it and learn about it and keep moving forward. The other side of that is, smaller shops, it got to keep the education side of it. And one thing that smaller shops can offer is that customized service. And a big shop, no matter how much they try, having that custom service, it's hard to get there. It's hard having a different face every time that customer comes out versus a small shop. They know who they're getting. They know it's you, and they depend on that, and they trust you. And it's very important that you maintain that trust. Whereas big companies now get the reputation of, hey, they're just trying to sell us something. They're trying to sell us another new unit again. So, you get into business side, which is, not my specialty, but if you get mad about all the regulations and changes, you're just going to spend your whole life being mad. What you can do is learn about it and navigate it the best you can.
Yeah, both Matt and Joe are both small shops who have made a go of it and are making a go of it. So, any comments from you guys about that?
For me, I have not found it. I have not personally found it difficult to keep my prices competitive, or make a good profit. And I don't know exactly why that is. I think I've had a lot of help with pricing stuff, and I have pretty low overhead. So I think it's hard to figure out. I don't know. I have not personally experienced a lot of what this comment is kind of getting at. In terms of like the equipment being more complicated, my hope is that a lot of this stuff is just not going to break for a long time. If you do it right from the beginning, you're pulling good vacuums, your static pressure is in range. Like a lot of the really expensive stuff, you're pretty much just going to be swapping an evaporator coil. Like I think that seems to kind of be the general wisdom, is if you get a lot of this stuff right from the beginning, and maybe that's the old equipment was much more forgiving about those types of things, and the new equipment isn't, and maybe that's where we're kind of seeing the disconnect. But I think it's certainly a good thing to ponder. So I'd like to hear Joe's thoughts on this.
Yeah, I'd say there's a competency crisis in every field, especially ours these days. So if you can be competent and give extremely good customer service, I feel like you will, regardless, and that's obviously, like Ty said, easier for small shops to do that. But that's kind of my focus. It's competency and customer service, because it's lacking these days. I mean, don't get me started on parts houses. I'd like to open a parts house too, and I think we could, make a lot of money there.
Parts house with a self-checkout, just for the small stuff, like capacitors and contactors. You can just go in and just pay for them with a scanner. I'm just saying, it's brilliant.
All right, I'm going to go on to this is an example of the sort of thing that you're going to have to come to the symposium to talk to me about. We have a definite mikvah inside joke with Eli and many of my Jewish community friends, but we will save that for another time. I like this question though, to kind of, as we're starting to get to the end of this, because this is one of the most common confusions that I see for new techs out there. So what exactly is common? I was told it's ground, but I saw it providing power to fan and Herm. And I'll just tell you, one of my first rants that I ever posted on HVAC School was about this, because I saw a rep at AHR selling a certain very common brand of hard start kit, saying that his 3-wire kit is safer because it comes with a ground on it, and the others don't have a ground, and because common is ground. And I just I had never run into reps before, so I didn't know. I thought when somebody was teaching something, that meant that they actually knew what they were talking about. And so I pitched a little fit and stomped around and wrote an article about it. But no, common is definitely not ground. That is not what common is, and it means a lot of different things. So Ty.
It's just because it's common doesn't mean they're all together. I have friends in multiple different circles, and each of that individual circle has something in common, but you put them together and that common means different things. So if you look at a capacitor, there's a terminal that's being shared. There's a dual run, so there's two capacitors in there. So one of those terminals is being shared. So they have that capacitor has something in common. A compressor has a run winding and a start winding. Instead of having 4 wires coming back from the compressor, they just share one of the terminals. So the compressor has something in common, but the common of the compressor is opposite of common of the capacitor. So just because it's a C terminal doesn't mean it gets along. And then you have common for a transformer, and that is a complete different voltage entirely and a separate circuit from all the other commons. So the common just means of that component or just of that one circuit, not that all the commons have anything to go together. And it's certainly different from ground.
Yeah, for sure. It just means it has something in common, like you said. Common on the compressor, you have a common terminal between start and run. Common on low voltage means the common point that everything returns to the other side of the transformer. Like you mentioned, capacitor, common point between the two capacitors. It means something different in every single application. So just recognize it is not a universal term. And I've seen people take, I've got the blue wire in my low voltage, put it on the C terminal on the capacitor and burn everything up. So I actually had it happen recently where a rep contacted me because he tried to replace his own capacitor and hard start kit. And that's what he did, connected it to low voltage common. Neil Comparetto asks, who's going to make the first AI service tech tool? Just because it's Neil, I had to put it up there. Any thoughts? Anybody seen any good AI service tech tools yet? Or do you have any old man grouchiness about it? Oh, you're making it.
Oh, yeah. Yeah.
Okay.
It's about to be released, so stay tuned.
Right. So everybody else should just give up.
Is it just a phone line to Joe?
No, of course not. It's a fully robotic service tech tool.
Oh, an actual robot tech.
Yeah.
Okay.
Yeah.
All right. Good.
Yeah.
I just think it's great to see Neil. I that guy's awesome. So thanks for stopping by, Neil. I've seen several companies. I've had some. I can't talk about them, but they've had some AI that I got to try out, and really what it is just source information. So it's like the Onion puts out fake articles, and you'll get those replies. So if there's a lot of stuff saying, it's always a TXV, like it will literally tell you, it's probably the TXV. And I was like, you need somebody training this. So you need a tech person training it. So I think eventually we'll get better, but what I've seen hasn't impressed me.
Yeah, the fun part for me is when I've searched, I use Chat GPT and Gemini for different things, and a couple times I've used them to just double check something that I was about to say, and then it will return HVAC school as a source with the answers. So that's always a little bit fun. Which means that I definitely can't trust the answers. Then it's like I was trying to get an expert to answer this, not that nerd. All right, we're at the end here. I want to just do this last one because this is one of my favorite topics. Are soft start kits bad for a system in the long run? And what about hard start kits on new units? Here's the important thing. A lot of the stuff that we used to call soft starts aren't soft starts. They're just a different kind of hard start. So I have to know what you mean by that. And so if you're talking about the big old box that mounts on the outside of the unit, a couple different brands make them. Copeland makes one. The other one is made by I can't remember the name of the company. Micro Air. And I think there's some others. No, they're great. I mean, they work well. I haven't had any issues with them. You guys can comment, but the basic idea is really good. They actually start a compressor slow, and it's not like a typical locked situation. So a soft start is actually good for a compressor in the long run. It doesn't hit it with a bunch of torque. You don't have that initial starting heat. And they're great if you have generators, but they're expensive. So they're costly, I guess I should say. So they're certainly not going to, as long as they're installed correctly and sized correctly and from a reputable company, they're going to work great. Hard starts, on the other hand, are good for certain applications, especially when manufacturers call for them, when you use manufacturer ones, but using it as a catch-all to try to, save the compressor is a bunch of BS. It's more likely to actually do damage to the compressor than save the compressor. But again, apply it when the manufacturer says to, and in situations where it's needed in order to get a customer some cold air. Makes sense, right? But it's not a one-size-fits-all solution, certainly. That is my take. Do you guys have any thoughts on that?
So I worked for a major compressor manufacturer, and I got to see all the details on the other side of that I didn't realize before, such as when a scroll starts up. Well, first, there's a huge difference between a scroll and a reciprocating compressor in the design. You could put a hard start in probably any reciprocating and be okay, but a scroll is designed differently. They design it so if you have a flooded start, that the motor will actually stall out and trip. And if you put a hard start on there, now you've added torque. So now you have a flooded start, the motor has extra torque, and you're more likely to break something. Things like that, that you don't realize, you don't think about that deeper side. And then you're really putting more amps in. Well, they don't design the windings of that motor to handle that inrush current of those extra amps like they did back in the old reciprocating days. So, there's a design difference in there. And I can go on about this for a while, and I do, but understanding that it doesn't just this one thing that you upsell and it just makes it better and makes it last longer. It's not really true. It can cause damage in some situations.
Yeah, it's like most things. It's like, hey, if you're sick, you take medication, but you don't take medication to make your life better all the time. I mean, some people do, but it doesn't usually work out well. And so any medicine is also a poison if used at the wrong time and in the wrong dosage. And that's never more true than with these sorts of things with an air conditioning system. Great. Well, we're out of time. So we literally have enough questions that we could go for another 2 hours. I could do that, but I don't want to because I want to go to bed because I'm an old person now and I'm happy about that. So Joe, Ty, Matt, thank you guys so much for doing this. Everybody who participated, we're definitely going to do this again soon because that was a very strong response. Everybody who asked questions that didn't get answered, we will try to. I think we can find these later. I'm sure there's a way we can get them. I hope so, and add them to our queue of questions because we can. Now hold on. I just read this comment where Matthew says the other mic sounds better. To be honest, and that's just. I don't know who you are, Matthew, but you and I have a beef now. we be beefing. Is that what kids say? I don't think so. Anyway, Joe, we'll keep praying for you. Thank you so much for joining us, and God bless you and your family. And good night, everybody. Have a good one.
Yeah, thank you all.